So these are two 12-volt batteries which are connected in series. So positive and negative are connected up, and then positive and negative at 24 volt here run up to the motor. This is a 12-volt tap, so the negative is common, but this one is connected only to this terminal and this terminal, so that's 12 volts, which runs through the cable to here, where positive and negative at 24 volts are put into the relays. This is an on and off relay. These two are set to, by default, run up, and then when current is applied they swap and they run down. This is the 12-volt tap taken from only one of the two batteries, which goes to feed the relay driver. The relay driver is a set of smaller relays which turn the 5-volt signal from the Arduino into a 12-volt signal to trip the relays to turn the high current from the 24 volts back and forth. The Arduino powers the relay board over these 3 pins, and the Arduino gets its signal as to where the actuator is through this horrible debounce circuit, which runs on this rotary encoder. So the rotary encoder spins when the actuator is rotating. That's a little clear set of gears that I laser cut to fit in there. The rotary encoder tells the computer where the actuator is at. So this is the code. So it starts just by defining which pin does what. Then this is the setup. This is code for the encoder, and this simply prints onto the screen what it has to do. So I'll just load it up onto the Arduino, and then the serial monitor gives me feedback. So it's run this code here and printed this back on the serial monitor. Then next, this is a loop. This measures the position of the rotary encoder and then counts it to go up or down. Sorry. This is the loop, so this counts instances that nothing has happened, and when these instances reach 2000, the height is saved. There's 2 heights, one for the most recent and 2 for the one before that. These are the commands, so I can type in 0, 1 or 2 to stop, go up or go down, and I can type in 3 to repeat. This is the code to count where the rotary encoder currently is. These are the commands which are sent to the relay driver board here. So if I type freeze, so I type in 0, then each of the drivers is set to low, meaning they're off. So these all go back to their default position, which is completely off. If go down, then they're all on high, which makes it go down, or go up, then only one is on high. This is the complicated part for me, which is if repeat has been called, so if I've pressed number 3, it defines the repeat distance, which is the difference between the last 2 saved heights. It then defines a target height, which is where it wants to go to, which is the current height plus the repeat distance. Of course, that can be negative as well. And then it prints out going to the target height and tells you what the target height is. Then it If the current height is not the target height, so meaning that we're not where we want to go, if it's less, it goes up, and if it's more, it goes down. Once pulses equals target height, it stops. This is a piece of code which is intended to slow the actuator down as it gets closer, but I don't have that working yet. So I can run the code. So this uploads it to the Arduino. This is my serial monitor. You can see it's printed out the first section of code. Now if I press 2 and send it, that sent the code along, which drives the actuator down. Then I press 0, which freezes it, and the actuator stops. I do the same again, 2 to make it go down, 0 to stop, and there it's saved the height every time I stop, and I've got it printing out whether it's freezing, going up or going down. Now if I press 3, which is repeat, it counts it out and attempts to repeat, and it did stop, but not at the right position yet. So the next step is going to be to fix this code to find out why it's not freezing at the right time, which I think is to do with this function here, which is not equal to. So this is preventing it from actually calling the freeze function, so I think I just need to change the brackets there. The next bit will be to get the slowing down function to work so that it doesn't overshoot, and then after that I need to take the computer out of the equation. So this is the foot pedal, down to go up, well, down to go down, up to go up. This needs to be connected to the Arduino to replace the 0 and 1, and then I need to create another button for the repeat so that the computer can be taken out altogether. The next step then is to put the screen in and debug the whole process.